Hi everyone, this is lesson 11.2. Now, in the previous lesson we kind of discussed most of this. So in today's lesson, we're going to keep it pretty short, but we're looking at more than one independent event. And what an independent event is, again, just as a recap, it's an event that has that is not affected by anything else. For example, if I roll a dice and I get a 6, that is independent of everything else that's going on around it. But if I roll a dice and spin a spinner, well, the fact that I roll the dice has no effect on what I would have on the spinner. So the dice is independent of the spinner. So now we're dealing with more than one independent event. Now, the first is, okay, for instance, if a cafe offers four types of sandwiches, there's egg, egg salad, tuna, ham, or turkey. Here I only put three because I missed the turkey, but I have egg, ham, or tuna. So assume it offers three types of sandwiches, right? So you have egg, ham, or tuna, and you also have a choice of three different types of bread. Now, if you put this in a table or a tree diagram, this is what it's going to look like. You're going to have one independent event on top. You have egg, ham, and tuna, and you will have the other independent event on the bottom, which is white, rye, wheat, coming off of each and every single type of meat. Now, so you have one independent event right here, and if you have the other independent event right here. Now, if you were to switch them and put the type of bread on top, it would look the exact same. You would have white, rye, and wheat, and coming off of each of those, you would have egg. Oops, sorry guys. You'd have egg, ham, and tuna coming off of each of those. You'd have egg, ham, and tuna. Now, and then the way you calculate the total number of total number of possible outcomes is you would take your last line and add it up. So you have 1, 2, 3, 4, 5, 6, 7, 8, 9. So in this particular case, you would have a grand total of 9 outcomes that could possibly happen with these sandwich choices. Adversely, if you were to do this in a table, along the top side here, we have one independent event, which is your type of bread. And on the side, you have your other independent event, which is the type of protein or meat. I guess protein would be because egg is not a meat. Now, you could flip-flop. You could put this one over here, and you could put this one over here. It doesn't matter. Similar to that of the tree diagram, it doesn't matter which is on the top, which is on the bottom. This is just the way that I've chosen to organize it. And then after, you would have right here, you have your egg sandwich on rye, egg sandwich on wheat, egg sandwich on white. And then to calculate the total number of outcomes, you would just add them up. 1, 2, 3, 4, 5, 6, 7, 8, and 9. So again, in the same vein, you would have 9 independent, you'd have 9 total outcomes. Now, the difference between a, a tree diagram and a table is the tree, it doesn't have a sample space. The sample space being that which shows all of your outcomes, right? You'd have to have egg, white, egg, raw. You'd have to make a sample space that would look something like egg, white, egg, sorry, this pen is acting up, egg, rye, etc., 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 and list them all. However, with a table, you have all of these outcomes already listed. And moving on. Now, it tends to get a little more complicated when you have here, we have 3 independent events. So in this case, we have appetizers being one. You can get chicken soup or salad. We have main meals. You have cheeseburger, turkey, hot dog, or veggie lasagna. And you have drinks. Milk, chocolate milk, apple juice, or sparkling water. So you have 1, 2, 3 different independent events, all independent of one another. Now, the question is, how many possible combinations are there of meals you could get with this lunch special? Now, You can have 4, 5, 6, 7 independent events, and it gets to be a lot of work. You create a tree or a table, whatever you choose, it gets to be a lot of work. So if I were to create a tree diagram for this, it would look something like this. It gets big and huge, and there's a lot of options because right here you have to have your one independent event right here with your salad. You have to have your second independent event right here. Each one of these coming off of the salad, which is your protein, and then you have to have another independent event, which would be each one of the type of drinks coming off of each one of the types of protein. And then you do the same for chicken soup. So this table takes a great deal of time to do. And then, but however, it does work. You can calculate the total number of outcomes by just adding up that last line, the total. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So with salad, you can have, with salad, you can have 12 different events. And then likewise with chicken soup, you can have 4, 8, 12 different events for a grand total of 24 total outcomes of lunch. You have 24 possible combinations of lunch. Now, that can take a while. So there's a different way to do it. A simple, easy shortcut using multiplication. Now, that way is quite simple. You take the total number of outcomes in your first independent event, which are 2. There are 2 outcomes here, right? The total number of outcomes in your second independent event, which is 1, 2, 3. There are 3 here. And the total number of outcomes in your third independent event, 1, 2, 3, 4. Okay, so you have 2, 3, and 4. So this is how you do it. Rather than make this whole entire massive table, you can go 2, you have 1, 2, you can have 2 events here, you can have times 3 different events here, times 1, 2, 3, 4 events here. So 2 times 3 is 6, 6 times 4 equals 24. So there are a grand total of 24 different outcomes. Again, you have 2 here, so 2 times 3 times 4 equals 24. And that is a lot quicker than approaching it this way. Now that's how you calculate total number of outcomes with multiple independent events. Likewise, if we were to do this one, you can make a table. 2 types of ice cream. You could have up top, you could have your ice cream cones. You could have waffle cone, regular cone, and you could have 3 flavors coming off of each one. And you could make that, and in the end, you would have your total number of outcomes. Now, the different way to do this is you look at 2 and 3. 2 times 3 equals 6 outcomes. Same here, you have 5 shirts, 4 pants. You could write down your 5 different shirts up top and 4 pants coming off of each shirt. It might take you 2-3 minutes, or you do it simple. 5 times 4 equals 20 total outcomes. Same way here. 5 model sports cars, 3 different colors. How many possibilities are there? 5 times 3 equals 15. Whoops, I'm pressing the wrong button. Equals 15 here. 4 times 4 equals 16. What am I doing? Equals 16. This actually goes here. And last but not least, when you have 3 independent events, that's when it gets complex. Very similar to this whole tree diagram. You could also just do something simple like 3 times 4 is 4, 8, 12, times 2 is 24 possible outcomes. Pretty simple way to do it. Now, here are your key ideas. You can organize your total number of possible outcomes. For example, flipping a coin and spinning a spinner. You can do that in a table diagram. The beauty of the table is you have a sample space created and made up where you can count your 2, 4, 6, 8, 10 different outcomes. However, if you do a tree diagram, which is a little quicker to make than a table, however, you would have to make a sample space to count the outcomes after. I mean, you can probably look at this one and see there's 5 and 5 is 10, but when it gets more complex, you would need a sample space. And the easy way to do that is take the total number of outcomes on one independent event and the total number of outcomes on the other independent event, multiply them together, and then you get your total number of outcomes. So that is a short, simple, easy way to do this lesson. Now your task for today is pretty simple. You're going to do pages 423 to 425, and you're going to do 1, 3, 5, 7, 10, and you are going to omit that math length section in there. So again, 423 to 425, numbers 1, 3, 5, 7, and 10. All right, any questions? Please feel free to get hold of me. Thanks, guys.